After we talk about the array implementation for the queue, it is time for us to talk about the linked list implementation as well as the vector implementation. Linked list implementation is basically a special case for the list. However, this time, because queue has a front part and a back part, so we are actually need 2 pointers this time. That is something new. We will need a pointer to talk about where is the front of the queue and where is the back, which indicating the last element of the queue. This is going to be useful because whenever we try to add a new item, we can directly use this back pointer to link with the last element. If we don't have a back pointer, we can still use a front pointer to walk through all the items until we hit the null. In the next part, we will understand that's the last one. However, this obviously will take some loop, which is going to based on big O of n operations to find the last item. Therefore, having a back pointer is going to be much useful and fast and efficient for the in-queue operation. So you can see that we will have 2 pointers. One is the from, talk about where's the first item. The next part of the first item will link us to the next one. And when we goes to the end of it, we will have the last item point by the back pointer. So this is how linked list implementation for the implementation, basically. So to look into the basic functions, for the constructor, we only need to create 2 pointers, from and back. Both of them are null in the beginning. As long as my front equal to null, you can see that this is slightly different from the array implementation. So in array implementation, is front and back point at the same location. That is going to indicating is null. In linked list implementation, as long as front equal to null, that means there's nothing over there, and that is going to indicating it is the empty queue. Talking about a comparison for the linked list implementation as well as the array implementation, you need to see that in linked list implementation, we have 2 pointers. One is the from point at the first location, back is point at the last element. Unlike array implementation, because for the array implementation, back is actually looking at the next available location. So there's slightly different concepts between the two, but they both have front and back. For the front operation, all you need to do is try to retrieve from the data part, and you will be able to get the front operation. Obviously, you need to check whether or not this is an empty queue. If it is not empty, simply print it out or see out my front to the data part. And that's the majority of the functions. Now it is a time for us to look into in-queue and the-queue. For the in-queue operation, since we want to add a new item, obviously the first 2 lines is always necessary. Try to create a new node, so the operating system will go into the memory, finding an available space that satisfies the node data type, and then we want to remember that location. Once we prepare that, we can put the element part into the data, so that will be able to store the value of that. And therefore, that's the first 2 lines, and we have seen this many, many times. If the queue is empty, that means the first element is my front element as well as my back element. So both front and back will point at the new pointer location. So that is the easy case scenario. If it is not empty, then we need to link the new item to the back of the queue. So my back to the next part will equal to the new location that we created. So we have form over there, and all we need to do next is saying that now my back equal to new PTR. So you can see that that can successfully link the items to the back of the queue. For the queue, as long as it is not empty, the first element, which is point by front, is the element I want to do the deletion, which is the dequeue operation. So we have PTR equal to my front. And then make my front goes to the second item. So my front equal to my front to the next one, and then free the space, as simple as that. So if we take a look of the memory space operations and we try to see what's happening over here, all we need to do is, first of all, for constructor, set front and back equal to null. So they are null, and that's the preparation. If we try to see an in-queue operation, so to deal with the first two lines, what we can see over here is that create a new node, so that's corresponding step 1, finding a random location, and try to remember that by the new PTR location. So we set new PTR equal to that location, and then we put the data into the location. So you can see that on the slightly mistake. So if we say in Q26, we put 26 over there, and we will be able to store the value of 26 into the data part. And then we will go into the if statement, since at that time it is empty because front and back are null. So we will hit the special case scenario, which indicating is empty. So all we need to do is make front and back equal to new PTR. So both front and back are pointing at the location of 6. And that is the very first in-queue operation. So 26 over here. And now if we try to in-queue the second item after that operation, you can see originally front and back at the index of 6, 26 is over here. And to do the one more in-queue, we need to do the first two lines of the code. Again, operating system will try to find a random location, say A, which is 10 in aux number. So that new PTR equals to A, so we try to remember this location and make the data part equals to 5. So we have 5 over here. Now, since they are not the empty situation, so we need to follow the two lines of the code over here. All we need to do is make my back next to the new PTR. So originally back is here. The next part of the back will goes to the new location that we have, which is A. So we put A over here, and then the second line is making my back goes to the new PTR. And basically you can see that if we try to trace the queue, we will start from the front. First element is 26, go to address of A is here. This is my back, and then the data part is 5. So that is how we will be able to do the in-queue operation. To do the dequeue is pretty easy, probably even easier. To do the dequeue, indicating that I want to delete the element of front, so that we would supposed to take 26 away, and then make front equals to the second item, which is this location A over here. So what we're going to do is that make PTR equals to front. So PTR, try to remember PTR is this location, and then we try to make front equal to the next item. So you can see that we'll make front equals to the front next, which is A. So front will comes to here. And that is basically it. All we need to do is try to remember the free the space, depending on how memory is trying, operating system is trying to track whether or not it's available, saying that the easiest way is both locations are null, then that means it's empty. So we have free the space, and basically you can see now, if we try to look into the queue, front and back are both equal at the same location, which the element is 5. So indicating there's only one element in the queue. That is the idea of the linked list implementation for the queue. So now let's look into the easy one, vector implementation. For the vector implementation, you will see that the basic 5 operations are described over here. Create a space. We talk about this in the stack implementation of the vector. Creating the vector. If the vector size equal to 0, it is empty. Now let's take a look of this. In queue from and dequeue. For in queue, we basically need to add element at the back, which is actually the same concept of push. We will see that. For the front operation, retrieve the value of the first element. So basically, you can use index of 0 of that vector, then you can retrieve the very first item already. For the queue, that means you want to remove the element from the front. This requires slightly more complicated operation. However, it's still a function call. So let's take a look at this. In queue and front. So if we want to in queue add an element in the back, so basically this is the same with the push because it's the same concept. All you need to do is l.push back. Then that is actually the same thing with the in queue. For the front, retrieve the value of element from the front. There are 2 ways of doing that. The easier one that you already know is using L indicating the name of the vector with the index of 0, then you can find the very first item. However, the other one is use another function called L.begin, which will retrieve the very first element of the vector as well. The reason I'm talking about L.begin is because that will be necessary to use for the dequeue. So for the dequeue, it's a little bit more complicated in terms of the operating system try to handle, because you use this one, L.erase of L.begin. So you try to erase the first item. When you do erase, something magical happens. Because originally, you have the vector starting with index of 0, 1, 2, 3 until the size of the elements that you have. Once you use L.erase of L.begin, the very first index originally at the space of index 0 will totally disappear. So the index 1 become index 0, index 2 become index 1. So you can see that there's actually a more complicated operations in back of it, and therefore we need to use L.erase of the L.begin to successfully remove the first element. And that is basically the vector implementation. And therefore, there's actually nothing new but the dequeue operation, because you need to L.erase of L.begin. And besides that, everything is the same with the stack operation. So if we try to look into a queue program, you can see that we include IO stream. Again, don't forget about including the vector using namespace std, and then we try to have a print function over here to print it out all the elements that we have inside of the vector, which is working as a queue. So you can see that L.pushback, pushback, pushback, pushback. So you can see that we push back 5 elements, and when we try to print it out all the items, we're supposed to see 10, 20, 30, 40, and 50. And then when we try to use L.erase of L.begin, then we will be able to remove the very first item. Before we do that, you see we try to retrieve the front function. So you can use L of index 0, like I mentioned, as well as use L.begin. So there are multiple ways of doing that. So say now we remove the first 2 items and we try to output the queue again, we're supposed to see 30, 40, and 50. This is a very simple function, simple program using the vector implementation. Try this yourself, play with it, so that you can have a full understanding of how do we use the vector implementation for the queue. Because it is actually the easiest way of handling the stack and queue using the vector. And therefore, in the future, if you have writing some programs that requires the concept of using stack and queue, this is going to be your best friend. You probably don't need to implement in the array implementation or even the linked list implementation. However, knowing those things can help you develop the mind of a computer scientist. That's why we still need to talk about those. Thinking about those, the turning concept, try to turn a horizontal array into a vertical for a stack implementation, as well as like how do you link the original array into a circular array concept. All of those are very simple to achieve in terms of writing the program. All of those changes only happens in your mind, and that's why these 2 topics are so important in the computer science area. Finally, if you see that there are many overlapping between stack and queue, so if we combine the 2 things together, we actually call something pretty fancy called Squirrel. It's a quick stack, queue and stack hybrid model, and therefore you are able to use all the functionalities that provided by the stack and queue. You can see push and enqueue are actually the same thing. You can do pop, you can do top, so that you can pop the items away. You can retrieve the top of the item, which is the last element. You can also retrieve the first element, which is the from, and the dequeue is another operations that you will be able to do. So once you combine those things, they are easy to implement, and because they are spatial scenario for the list operation, but combining those things can provide you more functionalities. And that is the ideas I want to discuss with you guys in terms of the queue.